Happy morning, all of you. Happy morning. Okay. Today we are going to learn a new lesson, unit number 5, coordination compounds. Coordination compound. About the coordination compound. In the fourth lesson, we learn about the transition metals forms a coordination compound. Transition metal forms a coordination compound. We learned that. Now this lesson we are going to learn about the transition compound. Coordination compound. What is about the coordination compound? Here first we should be learn about that coordination compound and also the double salt. What is about the coordination compound and what is about the double salt? When two or more compounds in a solution are mixed together, when two or more stable compounds, we are taking the stable compound in the solution, are mixed together, we get one coordination compound and also we get a double salt. What is about the double salt? For example, what is about the double salt? We are also learning potassium, one of the double salt. We are taking more salt, potassium, double salt. More salt. That is about that ferrous ammonium sulfate. What is that one? Ferrous ammonium sulfate. Ferrous ammonium sulfate means ferrous sulfate, ammonium sulfate and also water molecules. Here, the double salt means two or more equal amount of salt. We have two or more salt combined to form double salt. Clear? Two or more salt, that is ferrous sulfate and ammonium sulfate. Combination we get double salt. Here, when this double salt undergoes to treatment with a qualitative analysis, we can find which are the ion present, maybe Fe ions, ammonia ions, sulfate ions, etc. ions we can be identified. That's one of the qualitative analysis. Next about in the double salt, the coordination compounds. For example, one of the complex I am taking about that potassium ferrocyanide, potassium K4FeCN6, potassium ferrocyanide. Here the potassium ferrocyanide, the first one is potassium, K plus potassium. Here we are saying 4K plus potassium ferrocyanide, FeCN6, 4 minus. That FeCN6 4 minus we are saying about that is the coordination entity. The potassium is we are saying about the counter ions. Which ions? The counter ions. So for the qualitative analysis, this coordination compound cannot be dissociated into ions. It's ion. Dissociate ions. Cannot be dissociate its ion. That is one of the important points. Coordination compounds cannot dissociate its ion. But double salt can be dissociated into its ions. That is about the coordination compounds. Let us we can discuss. One by one we can discuss. Then only we can be understand. Anyhow, Werner theory of coordination compounds. Werner theory of coordination compounds. What is about the Werner theory? That is about the Alfred Werner. One of the great scientists, he postulated one theory. He postulated one of the important theory that is called Werner theory. For this, he got a Nobel Prize in 1930. He got a Nobel Prize in 19. And also he found some structure of the compounds. He is the father of coordination compound. Who is the father of coordination compound? Alfred Werner. That's a very important scientist. Very important scientist. Let us consider the different colored compounds such as COCl3, 6 molecules of ammonia. COCl3, 6 molecules of ammonia. What's the color? Yellow color. What's the color means? Yellow color. One word question. COCl3, 5 molecules of ammonia. It is a purple color. COCl3, 4 molecules of ammonia. It's a green, violet, etc. Here I have some colors that will ask the one word question. And you should be today our learning objectives to learn about the Vernier's theory, our coordination compounds lesson. Vernier's theory, one of the 5-mark question, very important 5-mark question. Today also I am giving the assignment also. Please write the assignment this question. Vernier's theory. Our aim is to learn this question. Vernier's theory. Here about the limitation also having the 2-mark question. This is also repeating board exam question. So today you should be learn the Vernier's theory. Okay, only 5 points. Postulate of Vernier theory. What is about the Vernier theory? The element exhibit, the first point, the element exhibit 2 types of valency. The element exhibit 2 types of valency. What are they? Primary valency and secondary valency. Can you see? The element exhibit 2 types of valency. What are they? Primary valency and secondary valency. What is about the primary valency? Primary valency is referred to as the oxidation state. Primary valency refers to as what? Oxidation state. Secondary valency referred to as a coordination number. Coordination number. Clear? So 2 types of valency. What are they? Primary valency and secondary valency. Primary valency referred to as a oxidation state. The secondary valency referred to as a coordination number. The primary valency of the metal ion is positive in most of the case. Sometimes it may be 0. They are always satisfied by negative ions. Clear? For example, COCl3, NH3 6 times. Here the primary valency of cobalt is +3 and it is satisfied by 3 Cl minus ion. Okay. The secondary valency is satisfied by negative ions, neutral molecules or positive ions. Sometimes the combination of these ions. For example, COCl3 6 molecules. Here the secondary valency is satisfied by neutral molecules, that is called ammonia. Okay. Then the 4th point is an important point. The 4th point is we should be draw the structure about the 4th point. There are 2 types of pair of attraction around the ion or atom. There are 2 spheres of attraction around the atoms or ions. Okay. Here the inner sphere and about the outer sphere. Okay. The inner sphere and about the outer sphere. Inner sphere we are saying about that coordination sphere. What's about the inner sphere? Is about the coordination sphere. What about the outer sphere? It is about the ionization sphere. About the inner sphere, the groups present in the sphere is firmly attached to the metal. About the outer sphere, the groups is present is loosely bound to the metal ion. Clear? There are 2 types of about the directional nature, the 5th point. Here, the primary valency is non-directional nature, no direction, while the secondary valency is directional nature. This much is enough for the 5 mark. Okay, only the 5 point. We should be learn the 5 point is enough and draw the structure. What is about the first point? Can you learn the first point? The metal exhibit where 2 types of valency. What are they? Primary and secondary. Primary and secondary. Clear? The primary valency is referred to as the coordination state. The secondary valency is referred to as the oxidation state. Okay, very important point. Okay, first point. The primary valency of the metal ion is positive in most of the case. Some case it may be a negative. They are always satisfied by negative ions. Here, for example, COCl3, 6 times of ammonia. The primary valency of cobalt is +3 and it is satisfied by 3 Cl minus ion. Clear? The 2 points. About the 3rd point, the secondary valency is satisfied by negative or neutral molecules or positive or the combination of these all molecules. For example, COCl3, 6 types of molecules. The secondary valency is satisfied by neutral molecules of ammonia. The 3 points. Can you learn? About the 4th point, I told you about that there are two spheres of attraction around the metal ion. Clear? Two spheres around the metal ion. One is inner and another one is the outer. Inner we are saying about the coordination sphere and outer we are saying the ionization sphere. Okay, here the inner, what is about that? The groups present in the sphere is firmly attached to the where? Metal. About the outer, it is loosely bound, okay. And about the direction, primary valence have no directional nature. The secondary valence have directional nature. Please, we can draw the about the inner sphere and outer sphere. Okay, very important. We should be learn which one is the primary valency. Okay, primary valency I am giving the dotted line. Okay, the sphere I am giving dotted line. That is a 3 chloride ion. Okay, dot line. Cl dot line. And about the secondary valency, that is a solid line. That is strong solid line for ammonia. That is the center, one of the center cobalt I am writing. About the secondary valency, first I am writing the secondary valency. There are 6 molecules of ammonia is surrounded. The last final, the outer sphere, I am writing the Cl ions. Okay. Please all of you take the book, take the note, we can rewrite the structure. Okay. As per the Werner's theory, the complex can be explained. That is CO, Cl3, 6NH3, ammonia molecules. Clear? How can we explain? As per the inner and outer sphere of attraction in coordination compound. Inner and outer sphere of attraction in coordination compound. Listen all of you. This is one of the metal. This is the metal ion. The metal ion, we have two spheres. How much sphere? Two sphere of attraction around a metal atom or ion. There are two spheres. Okay, this is imagine this is one of the sphere. This is one of the sphere. The next one is again one more sphere. Okay. Total how much sphere? Two spheres of attraction around the metal atom or ion in a complex. The inner sphere is known as, this is an inner sphere. The inner sphere is known as coordination sphere. Which is sphere? Coordination sphere. Okay. The outer sphere is known as ionization sphere. Inner sphere means, which is that on coordination sphere, the outer is the ionization sphere. About the inner sphere, what is about the specialty character? The group present in the sphere are firmly attached to the metal. About the outer sphere, this is about the outer sphere. Here, the groups present in this sphere are loosely bound. Okay, loosely bound to the central metal ion. Anyhow, we can look at the example about this one example. How we explain the example means, the central metal is called cobalt. We are writing the cobalt. Okay, cobalt we are writing cobalt. Cobalt. Okay, cobalt. Here, first one is a coordination sphere. Okay. That we told that inner sphere. Okay, inner sphere. Next about the ionization sphere. Okay. Ionization sphere. Here, ammonia, NH3. Okay. NH3, ammonia. NH3, ammonia. NH3, ammonia. NH3, ammonia. NH3, ammonia. The solid line, okay, solid line, okay, ammonia. Next about A dot line refers to as here Cl ions. Okay, Cl ions. Next about that, Cl ions. Cl ions. Okay. So how much cobalt is there? 1 cobalt. How much chlorine? 3 chlorine. 1, 2, 3. Okay, we can say is about the primary valency. The dotted line shows that the primary valency. 1, 2, 3. Primary valency. About the secondary valency. Okay, about the secondary valency. 1, 2, 3, 4, 5, 6. 6 secondary valency. Clear? As per this theory about the Werner postulate about the cobalt chloride with 6 molecules of ammonia. Okay. Now we have to discuss about some of the complex secondary valency and about the ionizable number of ionizable valency and the number of non-ionizable valency in some complex. Okay, complex. One of the complex there is CO, Cl3, 6NH3. Okay, you can take another one, CO, Cl3, 5NH3. Clear? Next, CO, Cl3, 4NH3. Next, one more example, CO, Cl3, 4NH3. Next about number of ionizable or number of non-ionizable. We can take non-ionizable. Non-ionizable means what? In inner coordination sphere. Okay, non-ionizable inner coordination sphere. About the ionizable outer coordination sphere. Okay, how many non-ionizable and how many ionizable? Okay, the first one category. First one category is COCl3, 6 molecules of ammonia. Here having non-ionizable means 6 ammonia. How much non-ionizable? 6 non-ionizable. Okay, inner coordination sphere. Remaining, how much Cl is there? 3 Cl. Cl. This is about the outer coordination sphere. This is about the inner coordination sphere. We need 6 numbers. Okay. Next about the second one. 5 ammonia and also 1 Cl minus ion. Okay. 5 here you should be write Cl minus ion. Okay. Cl minus ion. Okay. And about here the second one is 5 ammonia and 1 Cl minus ion. Okay. 5 NH3 and 1 Cl minus ion. Then how much remaining? Out of 1 we get 2 Cl minus ion. That means number of non-ionizable means 5 ammonia and also 1 chloride ion. Okay. Ionizable means 2 Cl minus ion. The second one, the third one. Okay. Here also 2 ammonia and 2 Cl minus ion. That means 4 plus 2, 6. We need 6. Okay. That is 4 NH3 and 2 Cl minus ion. So 4 plus 2, 6. Remaining we have 1. 1 Cl minus ion is ionizable. Here also same like that only. 4 ammonia and 2 Cl minus ion. 4 NH3 and 2 Cl minus ion. 4 plus 2, 6. But the remaining one Cl minus ion. Okay, this is the following table. Illustrate the Werner postulation. Okay, anyhow, Werner theory has some limitation. Limitation of Werner's theory. What are the limitation of Werner's theory? Limitation. He explained about the number of properties of coordination compound, but he does not explain the color and the magnetic power, magnetic properties. Okay, limitation. Anything have one limitation. Okay, he does not explain the color and the magnetic property. That is one of the limitation. Okay, does not explain. Does not explain the color, their color and magnetic property. Okay, this is one of the limitations. This is for the 2-mark question. Here about the limitation, Werner's theory was able to explain the number of properties of coordination compound. He can explain the number of properties of coordination compound, but he does not explain. What he does not explain? Their color and the magnetic properties. Okay. Next about some 2-mark questions. Coordination entity. Coordination entity. Okay. Coordination entity. Coordination entity means it is an ion or neutral molecule composed of a central atom. Okay, clear? The coordination entity means it is an ion, one of an ion or neutral molecule composed of a central atom. The coordination entity is enclosed in the square bracket. For example, here we can be written as K4, Fe, Cn6. This is one of the complex, coordination complex. This is one of an cation. This is one of an anionic complex. For example, we can be say K4. This gives 4K plus FeCn6 4 minus. Okay, this is the complex. It ionized into K plus plus and FeCn minus Cn6 4 minus ion. This is one of the simple ions. Okay, simple ions. That means can be give simple cation. This is one of an ion. This is complex anion. Okay, complex anion, simple cation. Okay. Simple cation, complex anion. Here, this is one of the complex. Here the coordination entity is enclosed in a enclosed in a square bracket. Okay, enclosed in a square bracket. This one is called what? Coordination entity. I wrote here. This one I wrote here. This is called what? Coordination entity. Clear? Can you understand? What is about the coordination entity? The coordinate entity means it is enclosed in a square bracket. That is FeCn6 4 minus. Okay. How we get 4 plus and how we will get 4 minus, I will explain later. Okay. I will explain later. Now, this is about the coordination entity. Then, what is about the central atom or ion? What is about the central atom or ion? The central atom or ion is the one that occupies the central position in the coordination entity. The central position. And binds other atom or group of atom to itself. Okay, throw a coordinate here. Throw a coordinate covalent bond. For example, K4, FeCn6. This is one of the complex. This is the one of the complex. Here, which one is the central metal atom? This is which one is the central metal atom? Okay. Central metal atom. The Fe is what? Central metal ion. Fe. Don't write Fe. Fe2 plus. Okay. Which one is the coordination entity? This is a coordination entity. And which one is the central metal atom? Fe is the central metal atom. The central metal ion can be written as Fe2 plus. Okay. How will we get 2 plus means? I will tell you about the charge that calculation having. First you understand, try to understand that which one is the central metal atom or central metal ion. The central metal ion is Fe2 plus. Which one is the coordination entity? This is the coordination entity. Here Fe2 plus accept an electron pair from the ligand. Okay. Here Fe2 plus ion accept an electron pair from each ligand. What is ligand means? Cn is the ligand. Okay. The Cn is attached. I will explain next one. Next one is the ligand. Cn will be attached to the central, always attached to the central metal ion. Okay, clear. Therefore, here, how much coordinate covalent bond means? There are 6 coordinate covalent bond. How much coordinate covalent bond? 6 coordinate covalent bond. Okay. Here, what is the function of the central metal ion means? The central metal ion has the ability to accept an electron pair. This is one of the one-word question. What is the function means? The central metal ion has the ability to accept an electron pairs. It refers to as a Lewis acid. Okay, Lewis acid. Okay, here. It has an ability to accept an electron pairs. It refers to as a Lewis acid. What is about the ligand? Okay, next we can learn about the ligand. One of the complex K4 Fe is Cn6. Okay. This is the simple cation, complex anion. Okay, simple cation. K4 means simple cation, and the complex FeCN minus 4 minus 6 complex anion. Okay, yeah. I told you that this one is what? Central metal ion. Fe2 plus is the central metal ion. Which one is the ligand? Cn. Okay. Which one is the ligand? Cn is the ligand. Clear? Cn is the Cn minus ion is the ligand. How look? We can give one definition. What is about the ligand? The ligand means the ligand are the atoms. Ligand means what? One of an atoms or groups of an atom. Ligand means an atom or a group of atoms. Clear? What do you understand? What is about ligand? Ligand means it may be on atoms or a group of atoms bound to the central metal ion or atom. It will be attached to the central metal ion. Clear? What is ligand? Ligand means it may be an atoms or a group of atoms bound to the central metal ion. The atom of the ligand is bounded directly to the central metal ion is known as donor atom. Okay, clear? The atom of the ligand is bound directly to the central metal atom are known as donor atom. For example, K4 FeCN6. Which one is the ligand? Cn minus is ligand. Oh, ligand is, what is ligand? Cn minus. What is ligand? Cn minus is the ligand. Okay. Next about the coordination sphere. Okay. Next about what? The coordination sphere. Okay, first we will learn about the coordination sphere. Here, the complex ion of the coordination compound containing central metal atom. Okay, central metal atom. For example, K4 FeCN6. Okay, this is one of the complex. The complex ion of a coordination compound containing central metal atom or ion the ligand is attached to, it is collectively called coordination sphere. This is the coordination sphere. What is the coordination sphere? FeCN6. Okay, FeCN6 times is the what? Coordination sphere. Okay. And it is usually enclosed in the square bracket. Enclosed in the square bracket with a net charge, having one charge. Okay. The other ionizable ions are returned in the outside of the square bracket. Here, one of an ion. This is one of an ion. This ion is right on the outside the square bracket. It may be on the left side or maybe on the right side. Anyhow, as per here, K4 FeCN molecules having the K4 ions is right on the left side. So it is called as what? Counter ion. Which ion? The K4 is called what? Counter ion. Anyhow, this is what? Cn is what? Ligand. The ligand is attached to the central metal ion Fe2 plus, and totally this is called what? Coordination sphere. Anyhow, one more ion is present, should be present on the outside the sphere. Okay, that is called what? Coordination. That is called counter ion. Which ion? Counter ion. Clear? And the coordination compound K4 FeCN6 contain the complex FeCN minus 4 minus. And it is referred to as a coordination sphere. The other which is another, the K4 is other, is associated with K plus. This is associated with K plus is called counter ion. Which ion? Counter ion. Here. Next about the coordination polyhedron. Coordination polyhedron. Here about the coordination polyhedron, three-dimensional spatial arrangement of ligand atoms that are directly attached to the central metal atoms are known as coordination polyhedron. For example, K4 FeCN6. This is one of the complex. Okay. The coordination polyhedron is an octahedral. Okay. The coordination polyhedra is what? Octahedral. The coordination polyhedra of an Ni, one more example, NiCO4 times is a tetrahedral. 6 means, don't forget that, is a octahedral. Number 6 means octahedral. The 4 means what? Tetrahedral. Okay. Next about the coordination number. We can learn about the coordination number. Okay, coordination number. How can you find out the coordination number? Okay. One of the examples that way I am taking K4 FeCN6. Okay, this is the coordination number. For this complex, 6 is the coordination number. Okay, that how can you say means the coordination number of Fe2 plus is 6. Okay, in this complex, the coordination number of Fe2 plus is 6. You should be right like that only. Okay, don't write 6. Okay, in this complex, the coordination number of Fe2 plus is what? 6. Okay, Fe2 plus is 6. Then we can give a definition. What is the definition means? The number of ligand donor atom bonded to the central metal ion in a complex. What is the definition? The number of ligand donor atom. The number of ligand donor atom is bound to the central metal ion in a complex is called what? It's a coordination number. Okay, it's a coordination number. In other words, the coordination number is equal to the number of sigma bond, okay, between ligand and central metal atom. Here, in other words, the coordination number is equal to the number of sigma bond between where? Ligon and central atom. Here Fe2 plus containing how much ligon? 6 ligon. The 6 ligons are bonded. When bonded in different direction. So we are giving what? Number 6. Okay, clear? Next about the oxidation state. Oxidation state. Already we learned about the oxidation state. Okay. Now again we are going to learn about the oxidation state. Oxidation state. Okay. First I am giving the example how to find out the example means there one formula. How can we find out the formula means one of the net charge. One of the net charge is equal to oxidation state of the central metal plus number of ligon into charge on the ligon. Okay. Is what? Oxidation state of the central metal. Okay, oxidation state of the central metal plus number of ligon. Oxidation state of the central metal plus number of ligon into charge on the ligon. This is one of the formula. Okay. How can we find out the oxidation number? How can explain oxidation state in FeCN64 minus? How will you find out the oxidation state for this Fe? Okay, we can be taken as X. We don't know about that, so we are taking X. What is the net charge? What is the net charge of this complex? 4 minus. Clear? The net charge minus 4. Okay, 4 minus. We are writing minus 4 equal to. We don't know, so we are taken as X. X plus how much ligon is there? 6. Okay. So cyanide it have one value Cn. Cn have value is minus 1. Okay. Cn what is the value of Cn? Cn having I give the value. Cn having minus 1 value. So 6 into minus 1. Okay. Here 6 into minus 1. Here. Can you understand? First you write the charge. Total how much charge is there? Minus 4. You write the minus 4. You don't know Fe, so you are writing taken as X. How much Cn is there? 6 Cn. 1 Cn value is minus 1. So 6 into minus 1. So can you say what is the answer? Minus 4 X minus 6. So how do you write? X is equal to 6 minus 4. X is equal to plus 2. What is the charge? Plus 2. Clear? So we are writing Fe2 plus. What is the charge? Fe2 plus. Okay. The charge is what? Plus 2. So I am writing Fe2 plus. Clear? Can you understand? So we have a lot of here having. You should be right. Next about the types of complex. Okay, types of complex. Okay, types of complex. Here we can types of complex means cationic complex, anionic complex, neutral complex. Here types of the complex means classification based on the net charge. Classification based on net charge of the complex. We can be classified into 3 types. What are they? 1, cationic complex. Cationic complex. Number 2, anionic complex. Third one is neutral complex. These are the three types of complex. Okay. For example, cationic complex means the coordination entity must have plus charge. Okay, plus charge means we are saying cationic complex. Clear? Plus charge we are saying cationic complex. For example, cobalt NH3 6 plus. Okay, plus we are writing. We are going to write plus 3. Cobalt. There, cobalt. This is one of the complex. Cobalt. Here ammonia 6 plus 3. Having plus charge. So we are saying cationic complex. Suppose it having negative charge. Anionic complex. FeCN 6 4 minus. Negative charge. So we are saying anionic complex. Here negative complex. Suppose there is no charge. NiCO 4 times. No charge. We are saying neutral charge. Clear? Cationic complex means it must contain one of the positive charge. The coordination entity having plus charge. That is called what? Cationic complex. The coordinate entity, the net charge is having negative. So we are saying anionic. There is no charge. No charge means what is we are saying? Neutral charge. Okay, neutral charge. Clear? Okay. Anyhow, today we discussed about that Werner's theory. Werner's theory. Next about the types of ligand. What are about the ligand? Coordination entity, central metal ion, sphere, coordination polyhedron, coordination number, oxidation state, and the very important question is the types of complex. Okay, these are questions we learn. So all of you should learn that one. And anyhow, today our assignment is postulate of Werner's theory. Okay, postulate of Werner's theory. This is the assignment. Please write the assignment. Thank you all of you. Thank you. Have a nice day.